Some people are not a huge fan of synthetic division because it's like yet another method, but it still gets us to the same result. So I prefer synthetic division for certain types of polynomial division. In your assignment, you're going to have to deal with some synthetic division. Not a lot, but some. Good morning. Thank you. So synthetic division is an alternate method, meaning you can use this. You can also use the other method, which is using long division. So synthetic division generally takes up a lot less space. And when you get good at it, it generally takes up a lot less time. So it's definitely a preferred method for a lot of people with dividing polynomials for those two reasons: less space, less time. You need to make sure that when you divide, and this is like a key to this, so everybody listen carefully here. When you use synthetic division, it divides a polynomial. The polynomial divides a binomial of degree 1. Binomial meaning 2 terms. If you have a 4-term polynomial divided by a 3-term polynomial, you cannot use synthetic division. This process only works with some polynomial divided by a binomial, and specifically the degree needs to be 1 of that binomial. Meaning you can't have a squared with your variable on your binomial. It has to be a single factor of the variable. So the concept here with synthetic division, and it says right here, you might find this to be quicker and simpler, takes up less space, could take up less time once you get good at it. So after writing a polynomial in standard form, write the coefficients of the dividend. So after writing a polynomial in standard form, write the coefficients of the dividend. The dividend is the thing that is being divided. In general, that would be the thing that goes underneath your division symbol. So this would be the dividend, and the coefficients of this dividend would be just the numbers in front of the variables or the numbers by themselves: -4, 5, -2, -9. Those are the coefficients. So in this example here, the coefficients of the dividend are 3, -2, -53, and -60. And you can see those here: 3, -2, -53, and -60. We do not use the variables in synthetic division when we actually do the process. We use them, we reintroduce them at the end when we write the answer, but during the process, we just use the numbers. If the dividend is missing a term, use 0 as a placeholder. That doesn't happen on this example. I will include an example in our notes that does do that. So we'll come back to that. Write the constant of A. Write the constant A of the divisor x minus A in the box. Basically what that means is with your single degree binomial that is being divided right here, this is your divisor. The value of A here is 3. And basically what we're doing is we're figuring out what value of x inside of here makes this set of parentheses equal to 0. So what value of x makes the binomial equal 0? And what would that be? How would you make this set of parentheses equal 0? What value of x? -3. So that's the number right there. It's basically the opposite of whatever A is, right? If A is 3, you're going to put -3 here. If A is a -3, you'd put a +3 here. So it's whatever makes that set of parentheses equal to 0. Because it's a linear binomial, then it's usually going to be just a single value. It might change a little bit. We'll see what happens on the next page with that. But in terms of the setup, this is how it ends up setting up right here. So you've got your divisor, opposite value of A, and then you have your coefficients of your dividend. Coefficients of the dividend right here. So the process is this. Once you have it set up, you're going to multiply the number just written in the bottom row by A. So, bring the first coefficient down. That was in this last one as well. So the first coefficient in this little process here gets brought down underneath this line. This line is like our equals line or whatever you want to call it. So you bring down the first coefficient, and then we go through just sort of a repetitive process. We're going to take this value here and multiply it by the number in this box. So if you multiply 3 by -3, what do you get? -9, which is this number right here. Once you get to here, you're going to then add those two numbers. So once we get here, you're going to add those two together. So it says multiply by a and write the product. The product of the coefficient in a is 3 times -3, which is -9. Add the product and the coefficient. Product is -9. The coefficient is -2. If you add -2 and -9, you get -11. And then repeat the process. So -11 times -3 is what? 33. There's our number there. Add -53 and 33, and you end up with -20. Last step here is going to take this value again, -20, multiply it by -3. We get 60. That's this number here. And then you're going to add those together. -60 plus 60 is 0. What do you suppose the 0 is? That's the remainder. Yeah. So we have our remainder. And what we end up with here is remainder. And you'll notice this little box on the end here. That little box on the end will always include a remainder. And so if we go from right to left, we have a remainder, which means that this value here is the constant value. So we can say C. There's no variable with this one, which means the one to the left of that would be what? That number goes with. I got some things for you here. We got a lot of things here. Yeah. So after next to the constant, what value usually goes next? The value with what variable? X by itself. Yeah, this is the linear variable here, X. Sorry, that probably could have been read. And then the one next to it? X squared, yeah. So we're just following the regular like polynomial standard form pattern here. So if we go to the next page, let's take a look because we're gonna see an answer here. It says to write the quotients, which is the answer. So because the degree of the dividend is 3 and the degree of the divisor is 1, the degree of the quotient is 2. Now, you don't necessarily need to memorize that. You can always just work from right to left, starting with your remainder, constant, linear, quadratic, cubic if it happens to be. And so we had a remainder of 0, and then our constant was -20. Our linear term with x was -11, and our quadratic term with 3 was, our quadratic term with x squared happened to be 3. And so what I usually do with these ones is I'll just usually write the answer directly underneath because we can see once we have the remainder, the constant, the linear, the quadratic, we can just go ahead and write, all right, I've got 3 with x squared, so that'd be 3x squared. And then minus 11x. And then minus 20. And the remainder is 0, so we don't need to worry about a remainder. Which, if we think about what we saw yesterday, what that actually means is the original happens to be factorable. However, you haven't learned how to factor something like that. Right there. So, because you haven't learned how to factor anything like that, the synthetic division or long division is really the only way to do this. So I want to do two things with this. I want to show you that long division gives us the same answer. Well, actually, I only want to do one more thing with that. I'll show you that long division gives us the same answer. And then I'm going to give you another problem off to the side right here that we're going to work through together. And then we'll move on to the next one. So let's just do this problem just like we did yesterday. So let's use polynomial long division here just to show that it gives you the exact same answer. So our divisor, thing that's being divided is x plus 3. Our dividend goes underneath the division symbol because that's the thing that is being divided, which was 3x cubed minus 2x squared minus 53x minus 60. So we'll get us a nice review of yesterday's process. So it's the exact same problem. And what was our first step in polynomial long division? Yeah, how many times does x go into 3x cubed? Or what do you have to multiply x by to make it equal 3x cubed? It's the same question, just a different way of phrasing it. But what do you get? That'll be 3x squared. X times 3x squared equals 3x cubed. And remember, because the first term is a squared term, it's going to go above the squared term here. So we're going to write 3x squared. And then we're going to multiply the 3x squared by the x and the 3. So 3x squared times x is 3x cubed, which matches that term right there. That should always happen when you're using long division. 3x squared times 3 would be 9x squared. And then we're going to subtract. The 3x cubed will cancel each other out. And then we're going to have negative 2x squared minus 9x squared. What's negative 2 minus 9? Negative 11. So negative 11x squared. Then what? Yeah, bring down the next term, negative 53x. And then we repeat the process. X goes into negative 11x squared how many times? Yeah, negative 11x times. And then we're going to multiply negative 11x by x, which will give us negative 11x squared, which is the exact same term there, which is what we always want. And then negative 11x times 3 would be negative 33x. And then we're going to subtract. The negative 11x squareds will cancel. Negative 53 minus negative 33 would be negative 53 plus 33, which is negative 20. So negative 20x. Bring down the negative 60. And then do this one more time. X goes into negative 20x negative 20 times. Negative 20 times x is negative 20x. Negative 20 times 3 is negative 60. And we can see that we have the exact same values twice, which means everything will cancel here, leaving us with a remainder of 0. So the quotient ends up equaling 3x squared minus 11x minus 20, which is exactly what we got with synthetic division. There's no difference. So both of them get us to the same place. But if you notice about synthetic division here, if it wasn't written out 4 different times, you would only write it once. You'd only do this one time. So in terms of the amount of space it takes up, synthetic division usually takes up much less space. The long division takes up more space just by the way it works. All right, I'm going to give us another one to look at here. And let's see, let's go with 3c to the 4th power. I'm just going to write it right underneath here. So here's an example. We're going to go with 3c to the power of 4, right small here, plus 6c cubed minus 2c plus 4 divided by c plus 2. I told you I was going to give us an example where we need to use a placeholder if not every exponent is accounted for in the dividend. So you might notice that there's an exponent missing here in our dividend. Which one's missing? C squared, exactly. We have to account for that. That would be like the difference between writing, just give me a quick example here. You don't need to write this down. But if you were to write the number 704 and you wrote it as 74, you've missed the tens place, right? There's a term that's missing from that. So we need a placeholder 0 if we're talking about the number 704. Got to have a 0 in the middle in order for us to actually make that 704. Same thing here. If we're going to write this as a value, we need to write this including the c squared term, even though there isn't a number with it. So we need a placeholder of 0 when we're doing that. And that would be true even if we were doing long division. We didn't run into that yesterday, but even with long division, you would have to write 3c to the 4th plus 6c cubed plus 0c squared minus 2z plus 4 under your division symbol. So you always have to do that. You have to use a placeholder 0 for any missing exponents, even with long division, but also with synthetic division. So that's something to keep in mind. All right, so let's get this thing set up. The first thing that I usually do is I'll start off by putting a little box here. And then I'll place the value that needs to go in here based on the divisor. So again, this is just what value of C makes this set of parentheses equal to 0? -2, yeah. Or it's just the opposite of whatever number is with your variable there. -2. As long as this variable is by itself, if there's a number in front of it, we'll have to do something different. We'll see that on the next page. And then we're going to write out all of the coefficients of our dividend. So that's going to be 3, 6. What goes after 6? 0. Then -2 and 4. Yeah. Because if we look here, if you think about what standard form of a polynomial looks like, it goes whatever the highest number is, and then take away 1 from the exponent to get to the next one. If you take away 1 from 3, what do you get? 2, which isn't there. So we have to account for that with a placeholder of 0. It would be like forgetting to write in the 0 in 704 and just writing it as 74. So it ends up not being the correct number. And so we need to make this the correct number by putting the placeholder there. And then we got -2 and 4. And then we're just going to put a line right here underneath. And to set this up, the first thing we're going to do is bring down the first coefficient. So if we look over here, bring the first coefficient down, which means we have another first coefficient of 3. It won't always be that way. And so we're just going to bring that 3 down right here. From there, we are going to multiply the 3 by -2. What's 3 times -2? -6. And that goes here, underneath the 6. And then we add those two values together, and the result goes here. 0. These two numbers right here. Yeah. So the ones that are stacked vertically, it's just like regular addition, just add them together. The biggest difference between synthetic and polynomial long division on this particular step, like if you're thinking about an equivalent step here, this would be like the subtraction step on polynomial long division, but instead of subtracting with synthetic division, we're adding on this step. All right, so now we're going to take 0 and multiply it by -2, which is 0. And then 0 plus 0 is 0. And then we're going to take that 0 and multiply it by -2, which equals 0. And then -2 plus 0 is what? -2. And I'm going to just put the little dividing line here, because on the opposite side of that line is going to be any remainder that we have. What is -2 times -2? 4. And then 4 plus 4 is what? 8. So we do have a remainder this time. So here's our remainder. There's our coefficient. Here's our linear term. Here's our quadratic term. And then we have a cubic term this time as well. So in terms of the whole number factor that we have, it's going to be 3x cubed minus 2. Because in our answer, if we have coefficients of 0, we don't need to write those in the answer. We need them in the process as placeholders. But if you write them in the answer, they don't need to be there. So we're going to have 3x cubed minus 2 with what left over? Eight over c plus 2. Yeah, so plus 8 over c plus 2. Just like with polynomial long division, whatever your remainder is still going to go over your divisor as a fraction at the end. And we could use polynomial long division. We'd end up with the exact same thing. But this takes up a little less space. And it's just a process of multiply, add, multiply, add, multiply, add, multiply, add. It's a very repeatable process. However, it only works if you're dividing by a linear binomial. It can only be 2 terms. You can only divide by 2 terms. And the variable has to have a degree of 1. If it's anything other than 1, this process here of synthetic division won't work. All right, let's try a couple more on the next page and then we'll be done with these notes. So example 5. We still have a linear binomial that we're dividing by 2x minus 1. However, in order for us to actually use synthetic division, not only do we have to have a linear binomial, which we do have, the coefficient, though, needs to be 1. Meaning we need to divide everything here by what in order to make the coefficient equal to 1 in front of the divisor? By 2, yeah. Divide out the 2 from everything. And because of that, if I was doing this one on my own, I probably wouldn't choose to use synthetic division. You can, but it's a little bit more cumbersome because you're going to notice we're going to have fractions involved. And so if we want to actually use synthetic division with this type of problem, because it is a linear binomial, right? A degree of 1 with our variable, but the coefficient is 2 and it needs to be 1. So literally everything has to be divided by 2. And if you divide everything by 2, 4 divided by 2 is 2. Negative 37 divided by 2 is negative 37 halves. 4 divided by 2 is 2, and then 9 divided by 2 is 9 halves. And then on the denominator, 2 divided by 2 is 1, so 1x, and then negative 1 divided by 2 is negative 1 half. So we just get some fractions, which isn't necessarily a problem, but it changes how things work a little bit. So x minus a equals negative 1 half. Therefore, the value of a that we're looking for is 1 half, because we're always going with whatever makes that equal to 0. Or just take the opposite value of whatever's with our variable. All right. So in our little box here, what number goes there? In the upper left box. 1 half. Yep. Then we're going to go ahead with the coefficients for the dividend, starting with 2, followed by how come? There is no cubed here. Good looking out, Cassidy. So we go from 4 to 2 here. There is no coefficient with x cubed because there is no x cubed. Therefore, we need a placeholder of 0. Then what? Negative 37 over 2. Make sure the negative is with it. Negative 37 halves. And then 2, followed by 9 halves. All right. So that's what we got there. And then our process involves bringing down the first coefficient, which is 2. And then we start the process of multiplying and adding. Also, off to the side here, maybe you read this. Missing terms, watch out. Add placeholders for terms that are missing from the polynomial. In this case, there are 0 x cubed terms. So we need that 0 placeholder for the x cubed term. All right. 2 times 1 half. 1. 0 plus 1. 1. 1 half times 1. 1 half. Negative 37 halves plus 1 half. Negative 36 halves, which equals negative 18 times 1 half. Negative 9 plus 2. Negative 7 times 1 half. Negative 7 halves plus 9 halves. Yeah, 2 halves or 1. So we've got our remainder of 1. We have our constant term of negative 7. We have our linear term of x. We have our quadratic term of 1. And we have coefficient anyway. We have our cubic coefficient of 2. And you can see right down below here, the resulting expression is 2x cubed, right there, plus x squared, right there, minus 18x, right there, minus 7, right there, with a remainder of 1 divided by the divisor, which when we divided everything by 2 was x minus 1 half. So there's our answer. And what it's asking us to do now is to simplify this, because if you're in simplest form, you can't have a fraction on the denominator, this is another reason why I don't think I would use synthetic division for this one. Because in order to simplify our denominator, we need to multiply everything on the numerator and denominator by 2. And the reason for that is you have to make this a whole number down here. And so the way you make 1/2 a whole number is multiply by 2. So if you multiply by 2 on the numerator and the denominator, you end up with 2 on the numerator, and then distribute the 2. 2x, negative 1/2 times 2 is negative 1. So really, we're looking at 2x cubed plus x squared minus 18x minus 7 plus 2 over 2x minus 1. Because 2x minus 1 was the original divisor. Not my favorite thing to do with synthetic division. I probably would go with long division on that one. I generally use synthetic division only if this is like a linear binomial with a coefficient of 1, because then it just sets up real quick. You don't have to do any adjustment at the beginning or at the end. But since it's asking us to use synthetic division for this one, let's do that, and then we'll call it a day. So I'm going to set this up over to the side. Let's write this out. We've got ourselves 4x to the 4th plus 3x cubed minus 12x squared minus x plus 6 divided by 4x plus 3. Remember from yesterday that when you have something in parentheses taken to the power of negative 1, you can turn that into a denominator. So that 4x to the 3rd power to the negative 4x plus 3 to the negative 1 power, move it to the denominator, move it to the denominator, and you end up with 4x plus 3. Now, in order to actually make this work with synthetic division, what do we have to do? What's that? Divide everything by 4. Yeah. Which is the reason why I probably wouldn't use synthetic division if I was given an option on this one. So if we divide everything by 4, that's going to give us 4. Nope, it won't. It'll give us x to the 4th plus 3/4 x cubed. Negative 12 divided by 4 be minus 3x squared. Negative 1 divided by 4 be minus 1/4 x. And then 6/4 would reduce to 3/2, so plus 3 over 2. All divided by x plus 3/4. Kind of obnoxious. Any questions about that? Dividing by 4 on everything? We've got ourselves a linear binomial. Coefficient is now 1. So let's set up some synthetic division on this one. So in our box over here, we got 3/4. So we just take the opposite of that. So that'll be negative 3/4. That's the thing we're going to be multiplying by all the way through. Coefficients of the dividend. What are we starting with? 1. Then what? 3/4, yeah, 1, and then 3/4, and then negative 3, and then negative 1/4, and lastly, 3/2. Kind of nice. We weren't missing any exponents on that one, so we didn't need any placeholders of 0. Then we'll go ahead and get our answer line right here. I'm going to go ahead and box this off for whatever remainder we end up with. All right, procedure time. What do we do first? Bring down the coefficient of 1. Oops, I'll just change that. Okay, then what? Multiply. What's 1 times negative 3/4? Negative 3/4. What's 3/4 plus negative 3/4? 0. What's 0 times anything? 0. What is negative 3 plus 0? Negative 3. What's negative 3 times negative 3/4? Whole number times numerator. 9/4. Negative 1 plus 9/4. 2. Because that would be 8/4. Just negative 1 plus 9 is 8. 8 divided by 4 is 2, so that's 2. And then we're going to multiply whole number times numerator. -6/4, which makes me feel like we probably should have just left this originally as 6/4 because those are equivalent. So what's the remainder? 0. No remainder, which means we don't have to mess around with multiplying the remainder by 4, because that's what we would have had to do. Bless you. So remainder, none. Constant term, 2. Linear term, x. Quadratic term, 0. Cubic coefficient is 1. So the answer for this one should be x cubed minus 3x plus 2. That one ended up not being too bad just because we didn't have to convert anything with a remainder, but that is what we end up with there. So x cubed minus 3x plus 2. And with that, we've got ourselves 23 minutes of work time. So if you need to be working on anything, which I'm guessing everybody has something to work on,